Hello friends, welcome back to my channel. In this video, I am going to solve exercise question from book Topics in Algebra from chapter 4 Vector Space and Modules. Question is, if S is a subset of V, let A of S, that is annihilator of S, is set of all those homomorphisms F in V cap such that F of S is 0 for all S in set S. Prove that annihilator of S is equal to annihilator of L of S, where L of S is the linear span of set S. Proof. Here V over F is a vector space, and let us consider our vector space V is infinite. So for more generality, I have considered set S of vector space V as an infinite set. We may consider finite set also, and same result will follow for that finite set. So let us consider our vector space V is infinite and S is any infinite subset of vector space V consisting of vectors S1, S2, S3 up to so on. Then we know that linear span of S is set of all those vectors U which are of the form alpha 1 S1 plus alpha 2 S2 plus alpha 3 S3 plus and so on plus alpha n Sn, such that alpha I are scalar coming from field F and Si's are vector coming from set S. We call this as a linear span of set S. Now let us consider F in annihilator of set S, where F is a homomorphism. Now since F is in annihilator of set S, we will call this 1. We have F of S is 0 for all vectors S in set S. Next, let us consider any vector, say U in linear span of S. Now since U is in linear span of S, U will be of the form A1 S1 plus A2 S2 plus A3 S3 plus and so on plus An Sn, where these Ai's are scalars, unique scalars coming from field F, and these Si's are vectors in set S. Then we have, as this vector, then we have F of U is equal to F of A1 S1 plus A2 S2 plus and so on plus An Sn. Now since F is a homomorphism, we can write this as A1 F of S1 plus A2 F of S2 plus and so on plus An F of Sn. Now since F is in annihilator of S and F of S is 0 for all S in S, we have F of U is equal to A1 0 plus A2 0 plus and so on plus An 0. Since F of S1, F of S2 up to so on F of Sn are all equal to 0, and so we have F of U is a 0 vector. Now since U is any arbitrary vector in linear span of S, and we have F of U is 0 for that arbitrary vector, and therefore we can conclude that F belongs to annihilator of linear span of S, and we will call this as number 2. So from 1 and 2 we have annihilator of set S is subset of annihilator of linear span of S. We will call this expression as star. Next, let us consider a homomorphism F belongs to annihilator of linear span of S, and we will call this expression as 3. Now since F is in annihilator of linear span of S, we have F of U is 0 for all vectors U belongs to linear span of S. In particular, consider the vector U1 is equal to alpha 1 S1 and U2 which is equal to alpha 2 S1. These are two vectors in linear span of S from definition of linear span of S, where this alpha 1 and alpha 2 are scalars coming from field F such that alpha 1 is not equal to alpha 2, and therefore these two are the distinct vectors in linear span of S. Now since U1 and U2 are in linear span of S, and we know that linear span of S is a subspace of vector space V, therefore U1 minus U2 will be again some vector in linear span of S, and therefore we have F of U1 minus U2 will be equal to 0 since this F is in annihilator of linear span of S. Now as F of U1 minus U2 is 0, we can write this as F of alpha 1 S1 minus alpha 2 S1 is equal to 0. Again, as F is a homomorphism, this can be written as F of alpha 1 S1 minus F of alpha 2 S1 is equal to 0, which can be written as alpha 1 F of S1 minus alpha 2 F of S1 is equal to 0 since F is a homomorphism. Now taking F of S1 common, we can write this as f of s1 into alpha 1 minus alpha 2 is equal to 0. Now from this expression, we know that either f of s1 will be equal to 0 or alpha 1 minus alpha 2 will be equal to 0. But we know that alpha 1 minus alpha 2 is not equal to 0, as alpha 1 is not equal to alpha 2. So we must have f of s1 is equal to 0. Similarly, we can prove that f of si is 0 for all vectors si in set S. And therefore, as f of si is 0 for all vectors si in set S, we must have f belongs to annihilator of set S. And we will call this expression as 4. Now, from 3 and 4, we have annihilator of linear span of S is a subset of annihilator of S. We will call this expression as double star, and thus from star and double star we have annihilator of set S is equal to annihilator of linear span of S, and this proves our result.